Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hopefully everyone doing well today. Stay healthy, stay safe, and stay at home. So now I will show you the extra example on limit of trigonometric functions. So first of all, what you need to do is you need to know trigonometric identities. So here are the trigonometric identities with involving the reciprocal trigonometry. So we have cotangent x here. Cotangent x will be equal to 1 over tangent x and will be equal to cosine x over sine x here. So how about cosecant x here? Cosecant x here is equal to 1 over sine x. So how about secant x? So secant x is equal to 1 over cosine x. So how to remember? Easy. If you look at the third letter here, okay, this one cotangent. So cotangent x, so t. T is stand for tangent, and when we look at is cosecant, okay, cosecant, okay, write down like this, cosecant, okay, x. So the third letter is s. So s refer for sine x, okay, refer to sine x. So for secant, c, isn't it? So c is referring to cosine x. Okay, so now look at the example 1. We have x, limit x approach to 0. So x times with cotangent x. So first of all, what you need to do is convert it to trigonometric identity by using the trigonometric identities. So limit x approach to 0. So now you have x here and times with cos x over sine x. Okay. So now when we simplify it, okay, so write down as this. So x cos sine x over sine x. Then when we substitute x for 0, okay, so you will get 0 over 0. Okay, when you will get 0 over 0, what you need to do is separate this one. Okay, so limit, we have limit x approach to 0. So we have x over sine x here times with limit x approach to 0 for cos x. Okay, so now for this part, okay, how to make it similar with the property. So what we can do is we make it like this. So limit x approach to 0. So we have 1 over sine x over x. So times with limit x approach to 0 cos x. Okay, so now this one, for this part, okay, separate again for numerator and denominator. We put limit in the numerator and the denominator. So what we can do is write down like this. So limit x approach to 0 for 1 and also limit x approach to 0 for sine x over x. Okay, so times with limit x approach to 0, so for cos x here. Okay, now we can simplify all of this. Okay, we can do like this. Okay, I bring it up. So we have, okay, 1, it will be limit x approach to 0 of 1, it will be 1. Okay, so how about this part? Okay, this part, how about this part? It will be equal to 1. Okay, this one over 1. So how about we substitute 0 inside the x for cos x here. So what you can get is 1, isn't it? Is it 1? Yes, 1. So your final answer will be 1. So this is your final answer. So now look at another example. Okay, we have limit x approach to 0. We have cosecant 2x over cotangent x here. So the same with the previous example, what we need to do is simplify it first or separate it first. So, change it to the, by using trigonometric identities here. So limit x approach to 0, we have cosecant here first. So cosecant 2x, it will be 1 over sine 2x lah. So we have 1 over sine 2x here. Okay, here. So how about 1 over cotangent here? So this one, cosecant 2x times with 1 over cotangent x. Okay, so 1 over cotangent x, it will be sine x over cos x, isn't it? So sin x over cos x. Okay, so now what you can do is, okay, we simplify first. Okay, limit x approach to 0. So we have sin x here over sin 2x times with cos x. Okay, for this one, if we substitute x for 0, so what we can get is 0 over 0, isn't it? So what we can do is times with what? Times with 1 over x for both numerator and denominator. Okay, so write down like this. Times with 1 over x. This one times with 1 over x2. Okay, so then you can get limit x approach to 0. So here for numerator you can get sin x over x. So for denominator you have sin 2x cos x over x. Okay, now we separate limit for numerator and denominator. So we have limit x approach to 0 for sin x over x here. So limit x approach to 0 for sin 2x over x, and times with limit x approach to 0 for cos x. Okay, because this x only for sin 2x because we want to use this property. Okay, so no need to put under the cosine x. Okay, so because this one is multiplication, so just only one can get the x. Okay, so equal to this one, limit x approach to 0 sin x over x. For this part, okay, how to make it same as the property? You need to times 2, isn't it? Times with 2, up and down for numerator and denominator. So now you will get over this one over. So 2 limit 2 is constant, so take it out. So x approach to 0. So you have sin 2x here over 2x. Okay, so times with limit x approach to 0. So for cos x. So now you substitute 0 inside the x. Okay, and then what you can get here. Okay, I write down here. So you will get for this part you will get equal to 1. For this part also you will get 1. Okay, this one 1, this one also 1. So how about this one? Okay, you substitute 0 inside the x. So cosine x, it will be equal to 1. Okay, so write down everything. So you have equal to 1 for numerator. For denominator, you have 2 here. So 1. Okay, and then another 1 here. So it will be 1 over 2, isn't it? So now look at another example. Okay, you have limit x approach to 0 for x square, cosecant square, and 3x. Okay, okay. So now for the same as the previous example, what you can do is change it. Okay, change the cosecant. So you have limit x approach to 0 here. So you have x square. So for cosecant, you will have 1 over sine square, and this one 3x. So 3x here. Okay. So when you substitute x inside the x, substitute 0 inside the x, so you will get what? You will get 0 over 0, isn't it? So 0 over 0. So same with the previous example, where you can do is simplify it first. Okay. So simplify. This one got square. This one also got square here. So you can simplify like this. So x approach to 0. So x over sine 3x square. Okay. So now the limit can be inside the square. So it could be like this. So x approach to 0. Okay, inside the square. So x over sine 3x square. Then how to make it similar with this property? So what you can do is, okay, so equal to limit x approach to 0, so 1 over sine 3x over x. This one 3. Okay, so bring this one down. Okay, so you will get here square. So separate the limit for numerator and denominator. So you will get limit x approach to, sorry, got squares here. So you have 1 and limit x approach to 0 for sine 3x over x here. Okay, don't forget the square. Okay, so now, okay, I write down here. Okay, so it will be 1 over this one times with 3, isn't it? So times with 3. So you will get 3 limit x approach to 0. So sine 3x over 3x. So don't forget the square. Okay, and then equal to 1 over 3. Okay, this part you will get what? Yeah, sorry, this one. Okay, this part what you will get? Equal to 1, isn't it? So times with 1. So don't forget the square. Okay, and then square here. So you will get 1 over 9. So this is your final answer. So now look at another example. Okay, so we have limit x approach to 0 sine 3x over sine 5x. So what you can do is this one. Okay, we want to follow this property, so needs to times with 1 over x for numerator, and also denominator we times with 1 over x here. Okay, so okay, here, so you can get, so limit x approach to 0. So you have sine 3x over x over sine 5x over x. Okay, we separate the sine 3x with sine 5x. So here we write down the limit x approach to 0. So now what you can do is we want to follow the properties. So this one 3. So this one also need to times with 3. So the up and down needs to times with 3. Okay, numerator and denominator. Okay, this one also times with, oh sorry, not 3, times with 5. Okay, times with 5. This one also times with 5. So you will get, so this one equal to limit x approach to 0. So you have 3. Okay, 3 can move to outside because 3 is constant. So you have limit x approach to 0. So you have sine 3x over 3x. So over 5. Okay, 5 constant. So you can bring it out. So limit x approach to 0. So you have sine 5x over 5x. So following the property, so you can get this one over this one, it will equal to 1. This one also will equal to 1. Okay, so write down 3 times with 1 over 5 times with 1. So you will get 3 over 5. So this is your final answer. So look at another example. So we have limit x approach to 0. We have cotangent 2x over cotangent 5x. And what you can do is you can separate both cotangent 2x and cotangent 5x. So this one, okay, make it like this. X approach to 0, this one x. Okay, you have cotangent 2x times with 1 over cotangent 5x. So here, for cotangent 2x, you can change it to, okay, limit x approach to 0. You will have what? Cosine 2x over sine 2x. So how about 1 over cotangent 5x? Actually, that one you will get, you can make like this, okay, because of 1 over cotangent. So here we'll get sine 5x over cos 5x. So for cos, you can separate cos, and also you can separate sine 2x also the sine 5x. Okay, like this, x approach to 0 for sine 5x over sine 2x times with limit x approach to 0 cos 2x over cos 5x. Why I separate this one? Because cos over cos this one, when you replace, you substitute x with 0, it will be 1. So 1 over 1. Okay. So, but this one, it will be 0 over 0. So we need to times with what? 1 over x for numerator, and also denominator, we times with 1 over x. So you will get equal to limit x approach to 0. So sine 5x over, sorry, not 5. Okay, x here. So over, you have another limit x approach to 0. Sine 2x over x here. Okay, so how about the cos? The cos you can substitute 0. So you will get 1 over 1. Okay. So how about the sine? This one, the left part. Okay, this one can times with 5. This one also times with 5. Okay, for here, we need to times 2 and this one times 2. Okay, so what you can do is bring 5 to the outside. Okay, so limit, because 5 is constant. So limit x approach to 0. So you have sine 5x over 5x here. So over, now you have 2. So limit x approach to 0. So you have sine 2x over 2x. So it will be 5 times 1. So over 2 times 1 equal to 5 over 2. So this is your final answer. Okay. So let's take a look at another example. Okay. So here we have cosine 3x over cotangent 5x. Okay, so this one, okay, similar with the previous example, what you can do is separate. Okay, make it separate first. So this one for cos 3x times with limit x approach to 0 for 1 over cotangent 5x. Okay, so for cotangent 5x, you can use this identity and change it, the sign in the numerator and cosine in the denominator. Okay, and then what you can get is limit x approach to 0 cos 3x. Oh, this one, because of cotangent 5x, and we have tangent here. So if we move the tangent like this, so we change with the tangent. So we have tangent x. Then it will be okay because no denominator here. Okay, I mean we don't have any 0 over 0 here. Okay, so now substitute x with 0. So you have 1 here, and for tangent you have 0. So 1 times 0 equal to 0. So this is your final answer. So look at your last example. So for this example, limit x approach to 0, you have cosine 3x minus 1, so over x squared. Okay, so this one, if you want to use this identity, is not valid because of you don't have any reciprocal here. So what you can do is, because we have minus sign here, so we can use conjugate. Okay, we can do it by we can solve it by conjugate. Okay, so what you can do is times with cos. Okay, write down first. You have limit x approach to 0. So cosine 3x minus 1 over x squared times with cos 3x plus 1 over cos 3x plus 1. Okay, so for the numerator, you can get equal to limit x approach to 0. You can get cos square 3x minus 1 square lah. Okay, over x square here. Okay, times with cos 3x plus 1. Okay, Then, now we use trigonometric identities, which is this one. So sine square x equal to, sorry, not equal, plus with cos square x equal 1. Then this one, okay, we can use, okay, sine square x equal to 1 minus with cos 2x. Okay, so we can apply this identity to this equation, this limit. Okay, so now what you can do is bring negative, factorize the negative. Okay, so factorize here, so we have negative 1. So limit x approach to 0, we factorize this one. Okay, factorize, you can get 1 minus cos square 3x. So over x square, so you have cos 3x plus 1 here. Okay, and then apply the identity here, you will get sine square 3x here. So write down negative 1, and then limit x approach to 0, we have sine square 3x here. So over x square, separate this one. So limit x approach to 0. So you have 1 over cos 3x plus 1. Okay. Okay. So now, okay, use the identity. This one. Okay, the property of trigonometry. So what you can get is this one equal to negative limit x approach to 0. So you have, oh sorry, not this one. Okay, make it here. So limit sine 3x over x square. So times with limit x approach to 0. So now, okay, you have cos 3x plus 1. Okay, so I bring this one here. Okay, so you have negative, and then this one times with 3, this one also times with 3. So you have a bracket, okay, a close bracket here. So 3 limit x approach to 0. So you have sine 3x over 3x. Okay, so then, so this one settle. Okay, so times with 1 over cos 3x equal to 1. So 1 plus 1 equal to 2. So this part settle. So now you have negative here. Oh sorry, this one square. Okay, sorry. So you have 3 times with 1. Don't forget the square. So you have 1 over 2. So now you will get your answer negative 9 here, because 3 square. So over 2. So this is your final answer. So don't forget to do your tutorial. Anything you can ask me. And thank you. Have a nice day.